Hi everyone, so in this video we are going to cover how to study digital electronics for GATE examination. We will see for EC, electrical, instrumentation and even for CS guys as well. So we will study what all syllabus are there, how much marks it is asked for, then we will see what all things you need to cover for a particular branch and how you can cover, how much depth you need to go and from where you can practice the questions. So everything that we are going to see now. Okay, so let's start with the first slide. So this is the syllabus mentioned. We will talk about the syllabus deeply, but on a top level, if we see, this is the syllabus mentioned of electrical, this is the syllabus mentioned of EC. Instrumentation has different syllabus mentioned, but the things are almost same. Almost the same thing are there, so that would work for instrumentation guy as well. And this is the syllabus mentioned for CSE guys. And marks distribution, EC and instrumentation will have it for 9 to 10 marks, and electrical and CS will have it for 4 to 6 marks. So that is the general trend. Okay, in CS, I guess in 2019 it was asked for 9 to 10 marks. Digital logic was asked for 9 to 10 marks in 2019. So that may also happen, but this is the general trend, 9 to 10 marks for EC, instrumentation, and for electrical CS 4 to 6 marks. Okay, so let's start with the syllabus. So this I will call in basics: Boolean algebra, logic gate, representation of Boolean functions, K-map, number system, codes and their arithmetic. So this is the basic part which is there for digital electronics syllabus. From where to cover it, I will tell you, but now how to proceed as per your branch. So let me write down. EC guys will cover it completely. Okay, like completely whatever that is there, you need to cover the video lectures, or if you are studying from any other resource, or if you are studying from the textbook as well. So completely you need to study plus questions plus PYQ. So everything you need to study for EC guys. Same goes for instrumentation as well, and same goes for CS as well. But electrical guys, in their syllabus, this is not mentioned specifically. Number system is not mentioned specifically. K-maps is also not mentioned specifically, but if they are asking combination circuit, that means K-map they have mentioned. You just need to consider that if we are saying combination circuit, that means K-maps is there. If they are saying combination circuit, that means Boolean expression is there. If they are saying combination circuit, that means logic gates is there, and same goes for Boolean algebra as well. So this is not specifically mentioned, but it is there in your syllabus. What we have seen in the general trend, that they are not asking much questions in electrical from this topic. But if you do not study these topics, then you are not going to understand digital electronics at all. So for electrical guys, study it. Okay, whatever the question I am solving in the classes, just solve those problems. That's it. Just study this and solve only those problems which are asked in the classes. No need to solve PYQs. No need to solve PYQs. Because these will not come in your examination. We are studying it only for understanding digital electronics. So on the top level, we are going to study it. Whatever the time I am spending in the class, the same time you need to spend in the class. Just I am teaching, you are revising the notes, that's it. You do not need to solve more problems on that, because that will not be coming in your examination. This is I am saying for electrical guys. For EC, instrumentation and CS guys, you need to cover it thoroughly. Well and good. Okay, let's move to the next slide. But before that, let me erase all. So from where you are going to cover it? So these two marathons are available on YouTube from my side only, from Himanshu Agarwal on PrepFusion channel. It is available, and the kind of content you are going to get, I will not talk much about the content. You will just go and see it. In a complete depth, I have covered whatever that can be asked in your examination and whatever that is required for your examination at a certain level. So that I am covering. Just a second. Yeah, so I was saying these two marathons are there. These are not crash courses or anything like that. These are full comprehensive courses. You will realize all the content is there. Do not go with the timings that are only 12 hours and 9 hours only. There are a lot of content. Since this is a recorded content, so I make my own content first, then I teach there. So there is zero time waste. Like I am not even wasting the time in drawing the diagrams as well. Diagrams are also already drawn. Whichever that is required, these are already drawn. Okay, so no time waste is here. You will definitely love the content, so you can cover it from here. Okay, let's go to the next one. Let's go to the next slide. Combination circuit. In combination circuit, these are the topics, and it is important for EC, electrical, instrumentation and CS. For everyone it is equally important and very important topic. So like parity generator, checker, code converter, magnitude comparator, mux, demux, encoder, decoder, priority encoder, then all kind of adders, half adder, full adder, then binary parallel adder, ripple carry, binary parallel adder, ripple carry adder, both are the same things. And then carry look ahead adder, delay based problems, very important in CS as well. a very good questions has been asked, like a lot of good questions has been asked on delay based problems. So these are also very important. And then all kind of arithmetic circuits like BCD addition, XS3 addition, BCD subtraction, all kind of these arithmetic circuits are also very, very important. So a very important topic for you. How you are going to cover it? For this as well, we have a free marathon available on YouTube, which is this one. Okay, and thoroughly I have covered. Like I will tell you which all things are required, which all things are the most important. So thoroughly I have covered. So let's just say you are studying from some other resource. So these are the most important things. Like in mux, they will be mostly these kind of questions are asked. Like they will ask you to implement a particular function, and they will ask that you are using 4:1 mux. You should use CD as a select line, and then what will be your input values, I0, I1, I2, I3. For that you will make an implementation table and you will tell your answer. So these kind of questions are very, very important when we talk about muxes. Just wait for one more minute. Yeah, so I was talking about muxes, and like magnitude comparator, these kind of things I have seen, like mostly they are taught on a very surface level, but you need to study all these things in depth as well, because these are the topics which haven't been asked yet. So these are in line. These kind of topics will be asked, like how would you implement a 2-bit magnitude comparator from 1-bit magnitude comparator, 3-bit magnitude comparator from 1-bit magnitude comparator, and how would you write down the expression? Like you would mug up the expression that I will write down the expression of 2-bit magnitude comparator, but what about 3-bit magnitude comparator? How would you write down the expression? What is the intuition behind that? So these kind of things you need to cover, like how to make 3-bit magnitude comparator from 2-bit magnitude comparator and 1-bit magnitude comparator. How many OR gates will be required? How many AND gates will be required? So these kind of things you need to cover. So everything is covered in that particular marathon. Okay, so you will definitely love it. And along with that, more things are there. Like in generally in priority encoder, I have seen n number of resources where this thing is taught absolutely wrong. Like in priority encoder, they will tell you just a standard circuit, and they will tell you with respect to the output, you directly make your output is given, and with respect to that, then you can directly write down the expression in terms of D0, D1, and D2, D D3. But that is not correct. You always need to make a K-map. This question I have taken, where if you directly write down the expression, your answer will be wrong. So you have to make the K-map there. Why you need to make the K-map? Because in priority encoder, if you do not click on any button, then what will happen? Don't care condition will come, and whenever the don't care condition comes, we need to make the K-map. So these kind of things are there. Okay, so certainly you need to study in that depth, so that you will be able to perform well in your examination, because these kind of questions are in line, and certainly you will see these kind of questions in future. Right, I am not writing down the things which are very common. Like I did not write anything from decoder, because decoder everyone will teach it, they will teach the same, but there are a certain few things which need to be focused on. So that I am telling here. And like these are the concept of delays, like you would make a full adder from half adder and OR gate, and how it would go with respect to different delays. There are different conditions. One condition will be where only A, B, C variables are mentioned. One condition where the variables are also mentioned, like 1 0 1 0. So different delays will be there, different analysis will be there. So these kind of problems are also there. So that certainly you need to watch, certainly you should study that. Okay, so yeah. And then we are making binary parallel adder from half adders, using half adders or using full adder. Using full adder as a block diagram, or using 2 half adders and 1 OR gate. So different analysis are there. And then if variables are mentioned like 1 0 1 0, then different analysis will be there. So these kind of analysis we have seen here. Okay, so this is the way, this is how we solve the questions. Like we will go to the each block and we will ask you whether it will wait for the carry or not. So then it will proceed. So these kind of things you should study from wherever you are studying. I am not saying you study from PrepFusion only. From wherever you are studying, you need to study these kind of things in depth, right? So these kind of examples are there. Yeah, and complete notes I have already uploaded on Telegram group. Okay, on Telegram group I have already uploaded the complete notes of PrepFusion from digital electronics, so that you can also study if you are not going for any paid courses from PrepFusion, or if you are not even studying from YouTube. So on YouTube as well there is a lot of content. If you want to study from there, then you can study, right? And like generally we do not see any delay based problem for carry look ahead adder. Like it is taught very in a very brief manner. Carry look ahead will be taught in a very brief manner, because not much questions has been asked, but they are asking good questions from binary parallel adder in case of delay. Then certainly you can expect some good questions in case of delay as well from carry look ahead adder as well. That how would you analyze a carry look ahead adder in the examination? What is the short way? How would you see a problem of delay? So this is what I have taught here. Okay, these kind of delay based problems also I have taught, and all kind of like subtractor, adder, these kind of circuit implementation are also very important, right? Now the most important part comes now, that is sequential circuits. So in sequential circuit, there are memory elements. First we will study about latches, gated latches and flip flops. Then we will move to like in gated latches there is a condition that is not a race around condition. To overcome that, we will study about master slave. Then we will study about binary ripple counter. Then we will study about non-binary ripple counter, asynchronous counter, shift register, how to decode these outputs, ring counter, twisted ring counter, and then we will see delay based problems. So these are very important for everyone: EC, electrical, CS, and instrumentation. Now coming to the finite state machine. This part. In the syllabus of electrical, it is mentioned sequential circuits. Okay. And FSM comes in sequential circuit only. You can say FSM is a extended version of sequential circuit, nothing else. In 2021, I guess, there was a question from FSM in electrical. There was also mentioned that sequential circuits only. FSM was not specifically mentioned. Still there was a question because it is a part of sequential circuit only. So electrical guys should study it, but again I am telling you, just need to solve all the questions which are there in the lecture. Okay, study it, but solve all the lecture problems. That's it. That would be more than enough for you. What I am saying it for electrical. For electronics, instrumentation and CS, you need to study thoroughly. Okay, sequential as well and FSM as well. But only for this part. And for electrical students, I am telling that you can study it on a surface level, not on surface level, whatever that has been taught in the class, that would be more than enough. You do not need to solve extra problems. Okay, for electrical students. Now after this, CS guys work is done. The work of CS guys are done. You can skip to the final part of the video. There I will be telling about the courses, or from where you can study the from where you can practice the questions. So for CS guys, this is the last topic, FSM. After that, you do not need to study anything for GATE CS, right? But electrical guys, instrumentation guys and EC guys will hold. So till now the things are clear. Okay, starting from the beginning, basics, electrical guys can study on surface level. All need to do, rest all you like EC, instrumentation and CS guys will be doing it thoroughly. Combination circuits, everyone will be doing thoroughly. Sequential circuits, everyone will be doing thoroughly. Finite state machine, electrical guys can be a bit slow, or you can say can study from surface level. Rest all guys will be doing it thoroughly. CS guys, your job is done, and EC, instrumentation and electrical guys will hold now. Okay, so let me erase it. Now for this particular part, there is no marathon available on YouTube because I cannot provide everything for free. I hope you also understand that. So for this part, there is no marathon available from my side. Okay. But there is next part, that is STA, static timing analysis. So electrical guys do not need to study it. Okay. Electrical guys do not need to study it. I am saying 100% the question will not come. Electrical guys can skip static timing analysis. But EC guys and instrumentation guys highly should not skip this part. I have seen a lot of teachers as well and a lot of students as well skipping this part because that is typical. So I have made a marathon video, or you can say 3 hours of video is there, which you can watch on complete STA. All kind of questions I have covered, like whatever the minute thing that can be asked, that has been covered in this particular lecture. Okay, so you can go and watch it. It is there on my channel, Himanshu Agrawal channel. So it is there on that channel. You just need to type static timing analysis Himanshu Agrawal. Okay, you will get it. And all kind of problems, like every certain thing that can be asked from STA, that I am covering, because I am highly hopeful that if a good question is coming in digital electronics, then it will come from STA only. So all kind of things I have covered, like positive trigger, negative trigger is there. Every kind of delay I have considered. So all kind of things are there which you can watch. Okay. Right now in sequential and in sequential circuit and FSM and STA, what all you need to cover thoroughly, so that I am telling now. So you are going to study latches, but everyone will study standard latches, but it's not necessary in the examination that only standard latches will come. So you should have the problem solving ability of solving a non-standard latch. So this is a non-standard latch. So how would you solve this particular non-standard latch? So that ability also you should have. So you can study the notes, or you can come to our paid course. From there you can study, or if you are studying from some other resource as well where you are finding the content good, that also you can study. Okay, so just the focus part I am telling. Now in non-binary counter, what is the typical scene? That they will tell you a trick, that how you design a clear input, how do you design a preset input, that for clear input you only look at once, for preset input you only look at 0. That is absolutely wrong. There is a certain condition when it will be applicable. If your counter is starting from a random number, this will not be applicable. If you are going up, that means if you are designing up counter, then you need to start from 0 0 0 only, then only this short tick will be applicable, otherwise it will not be applicable. And if you are designing down counter, then you need to start from 1 1 1 only, then only this trick will be applicable. So these kind of things also you need to cover, like from wherever you are studying, you need to make sure that if they are teaching that much depth or not. Okay, so that is required. Now in FSM, it is taught on a very surface level wherever we see, but from FSM as well, good questions are expected. And if you see the previous year trend, in 2022 as well, there was a question from FSM. In 2020, 2021 as well, 2018 as well. So they are taking the FSM forward. Okay, there will be questions from FSM, and very good questions will be coming. In FSM, what do we see? A diagram is given and we will ask what is the sequence detected. This is not enough. Like these kind of, if they make the circuit and they will ask you how many flops will be required to generate this FSM, what you will say? 5 flops? No, there is a redundant state. So how do you find that redundant state? How do you make the modified diagram? So these kind of things you need to cover in case of FSM. Okay, like more things are there in FSM. In FSM we never study these sequence detector diagrams, like how to design a sequence detector, Mealy, Murray, overlapping, non-overlapping, how to design it. Like what we generally study is that just a waveform is given, you go, sorry, just a state diagram is given, you go from until your output is 1, you keep on working. That would be not enough. What they are going to do, they will make this diagram half, like they will not make all the arrows, and then they will ask me that if I apply a particular input, where it should go if I am designing this particular Mealy machine. These kind of questions you will get in PrepFusion test series. There I am going to put these kind of questions which can be asked, because they are in NPTEL assignments as well. So regarding that I will tell you later on, but these kind of questions are there in NPTEL assignments. So certainly these kind of questions are in line and they will be certainly coming. Okay, so you should be comfortable with these kind of problems as well, that you should be designing as well. Like people will say that, sir, how they are going to ask the design? They are not going to ask the design, but they will make the design which will be half completed, and based on that they will ask you how to complete it. Okay, so that part also you need to cover. And generally what do we see is that only one sequence is detected in one state diagram, but it is not necessary. In one state diagram 3 sequence can also be detected. You see this particular question here, 3 sequence are detected. So how to design it, and if it is being designed, then how to analyze it? Okay, so this question was also there on, it was the problem based on FSM. So this was not based on FSM, it was actually based on sequence generation. So this topic is also not usually taught. These kind of questions has come and will come in a much in-depth manner. So that's why I am telling it that you need to focus this much on the subject. Okay, because this is a very good subject for VLSI and you are going to expect good questions from it, because the way IITs are framing the problems this year, from the way IIT professors are framing the problem, these kind of questions are in line. Okay, and yeah, like in STA, this is what I was telling, that only 2 flops need not to be there necessary, 3 flops can also be there. Like this is positively as triggered, this is negatively as triggered. So how to analyze that? Like in STA we generally study that all the flops are positively as triggered or all the flops are negatively as triggered. So how to analyze that? How to analyze with timing diagram, and what is the short way to write down the setup time and hold time and t clock values. So these are the things that I have taught. So STA you can study from that particular marathon only. Okay, so that's the thing about sequential circuit, STA, and our, what do we say, FSM. Okay, now data converter, it is a easy topic only, and if IITs are asking the problems from it, they are asking straightforward problem. In 2018 or it was in 2016 I guess, so there was a good problem on ADC that was based on the concept of sampling, because I told you one thing, that before the ADC there is a sample and hold block, so that is very important. So from there they ask the good question, from there again they can ask the good question as well. And switch capacitor ADC also they can ask, and sorry, not switch capacitor ADC, switch capacitor DAC also they can ask. So this also I am going to cover in one of the problem if I get the time. So that also I will cover. So these kind of things you need to cover in data converters and logic families. Yeah, so this data converters should be covered by whom? They should be covered by EC, electrical and instrumentation, all of them. CS guys do not need to cover it. Now logic families, here after data converters, job of electrical guys are done. Okay, so for electrical guys, what did I tell you? Basics on surface level. Okay, combinational completely, right? Then we came to sequentials completely, then FSM on surface level, and STA you can ignore, and then data converters completely. So that's it about your electrical syllabus. So is that complete for electrical guys, right? Now you have a clear picture what you need to focus on and how you need to proceed, because electrical guys can spend least time on it and they can score very well. Okay, so now this topic is not there in electrical syllabus, but it is there for EC and IN. Okay, so in the syllabus what is mentioned? CMOS implementation of logic gates. For instrumentation, TTL gates are also mentioned. Okay, for instrumentation, so they can also study TTL as well. So they can study TTL as well for instrumentation, only for IN. They just have mentioned TTL, but in last 5 to 6 years, never the question came from TTL. Okay, they just have mentioned it. So if you want to study instrumentation, guys, they can study TTL gate as well. Very small topic. It would be taking 30 to 40 minutes only. Okay. They have mentioned CMOS implementation of logic gates, so that is important. So that you can cover from anywhere, or I have also covered it. Then characteristics of logic families can also be asked. Like they have asked CMOS implementation. So that is a logic family, and that can have these characteristics, no? Fan in, fan out, propagation delay, power dissipation, figure of merit, noise margin. And on what basis I am telling it? So let me show you something. Let me erase it first. Then I will show you something. Now people will say that, sir, do we need to study CMOS? So in GATE 2022, this question was there that you need to find the correct statement regarding CMOS implementation of NOT gate. CMOS implementation of NOT gate. So what is mentioned in the syllabus? CMOS implementation of logic gates. So that's where they are asking it. CMOS implementation of NOT gate is CMOS inverter itself. That is a CMOS inverter only. Now in CMOS inverter, they are asking noise margin, then they are asking power consumption, and then they are asking this, what do we say? This is a simple characteristics only, and then they are asking about this is also comes under characteristics of CMOS inverter only. So these things they are asking. For EC guys, this was asked in EC syllabus. Why is that so? Why they are asking it? Because in the syllabus it is mentioned CMOS implementation of logic gates. This was a 1 mark question which came in 2022, but in future also it can come, no? So if you are having more than enough time, if you have started your preparation way long back and you are having enough time, then I would suggest you to cover CMOS VLSI. Otherwise you can drop it. In CMOS VLSI, what all things you are going to cover? MOS you will cover, MOS physics, right? And then you will study past transition logic. In 2022, past transition logic was also asked, but that we have covered in analog electronics itself. So that is not a thing to worry. In analog electronics, you cover past transition logic. And what else you can cover? You can cover after that you can cover this dynamic power analysis video also I have uploaded on my YouTube channel itself. If you have studied CMOS inverter from anywhere, you can study that. If you want to study power analysis, so that I have uploaded on YouTube channel. So you can just type power analysis of CMOS by Himanshu Agarwal. So you will get the video. Okay. So that also I have uploaded. Noise margin I have taught in the paid course, but I will try to upload it if you ask me. Okay. But yeah, these things are there. Now this CMOS VLSI is vast. Okay. It's not that it is very straightforward. It is simple if you study it in depth, but it is vast. So you cannot spend much time here. If you are having more than enough time, then only you should spend. So this is the point I wanted to deliver here, that this is only for EC guys. I am telling that CMOS VLSI you can cover, but if you are having more than enough time, instrumentation guys can ignore it. It will not come there. Very 0.1% chances are there it will come. Otherwise, even if it comes, you will drop the question. Okay. But if you are someone who is targeting like rank under 50 or rank under 60 or rank under 100, and if you are having more than enough time, then I would highly recommend to cover CMOS VLSI as well. Okay. And now programmable logical devices. This is one of the topics as well. There we study about PROM, PLA, and PLDs. So that also you can cover. Along with that, you can cover semiconductor memories as well. Okay, that will go for all instrumentation and EC students. So the job of electrical guys was done here. Here the job of electrical guys was done. But for EC guys and instrumentation guys, this was one of the important thing, and this was also, I would not say important, but if you have the time, you can study it. Okay, so yeah, that's it about the syllabus discussion. Now talking about the question practice, so you can from where you can cover the questions, PYQs you can do, test series you would be having from anywhere. Now NPTEL assignment, should you do that? If you want to do, you can do, but you need to filter out that whether it is relevant for GATE examination or not, because in NPTEL, if you see the digital electronics courses, so the courses will be very vast. They will be teaching like some concept of COA as well. Like if you go to the chapter of shift registers, so they will be teaching arithmetic shift register, shift left, shift right. Although we also taught it, we also teach it, but they will teach in a very in-depth manner. They will also teach microprocessor as well there only. So you need to see which question is relevant for your examination or not, or from where you can practice. You can get the PrepFusion notes. There will be questions. Along with that, I will design the test series as well. So from test series questions, some question I will be designing myself. Some will be designed by some of the some of the very good person like who is involved in this problem solving, and like who is a very good gate ranker. So some of the questions he will be designing, some of the questions I personally will be designing, and some of the questions I will be taking from NPTEL assignments as well. So I will design a very good test series. Roughly around there will be I would think at least I would try to take 130 problems. There will be 130 problems. So a very good kind of problems you will see there. So yeah, that's it about the question practice as well. So you can take the test series. You can, like, if you solve the PYQs is our priority. If you are done with PYQs, then you are going to come in these lines. First solve the PYQs. If you are done with that, then come here. Okay. So these are the things. These would be your enough practice resources as well. And if you want to study from us, you can study from PrepFusion. So these are our digital electronics course for 2026 as well, for 2025 as well. And the quality I can promise, like I would not say about the quality. You can watch the marathons available. You can watch on your own, and then you can decide whether the quality is good or not. From my side, I have given the best here, and definitely you are going to love it. If you want to study, just study combination circuit. These are the most complex topic for a lot of students. So just study those topics and see what kind of depth has been covered, and in a very easier language the things have been taught. Okay, and in a very good manner as well, like how to solve the problems in examination, that also I have taught. Okay, so these are the prices. So shall I reduce the price? I need to think about it. As of now, the price is 2000, and for this it is 2799. Very minimum price I am asking. Like if you go to any other coaching institute, they are not going to give you the course in such a least price. Okay, in such a less price. And if someone are giving, then you can study from there if you want to study from them as well. Okay, because I know their quality. Okay, forget about them. Let's not talk about other institutes. But yeah, if you are studying from here, if you want to study from here, you can study. And about the discount offer, because discount offer got ended yesterday only. Okay, so yeah, I can consider giving some discount. Let's make a code. I will make the code DG20. Okay, so 20% off. 20% off I can make on both of the courses. This is the last time I am giving any offer. Okay, and let's take it till 15th of October. 15th October, 11:59 p.m. Okay, so if you want to study digital electronics more in depth, you can cover. So DG20 means 20% off. So it will come down to 20% off. It will come down to 1599, and this will also come down. So that in that manner you can purchase. Okay, so DG20 will be your promo code, DG20, DIGI20. So I will generate it and it will be applicable. Okay then, yeah, thank you very much. I hope you found the video helpful. If you are having any other doubts, you can write down in the comment section. I hope I have given a detailed roadmap for what EC guys can do, what instrumentation guys can do, what electrical guys can do, and what CS guys can do. Okay then, thank you very much.